This looks complicated, but it can be solved through a basic method, long division. You probably learned long division many years ago, and most likely still remember the base principles of it. As you go through a problem, you continually have to figure out how many times are possible for the dividing number to go into the dividend. The same principle goes here. Let's take this problem for example. All the long division that we do is going to be based on the first term in the dividing polynomial. So, in this case, that's 2x. All we need to figure out is what multiplies with 2x to become 2x cubed. We should find that this is x squared. In regular long division, it is helpful to separate the digits by powers of 10, such as the hundreds place, thousands place, etc. We can apply the same principle here, by powers of the variable and constants. The next step is to put the x squared on the top of the bar, and we put it directly into the x squared column. Now, we have to multiply the dividing polynomial by x squared to get the difference between the terms, much like how we multiplied 16 by 3 to get 48 in the earlier problem. After we distribute the x squared, we can now subtract from the dividend by simply placing a -1 in front of the entire term. The first term should always subtract to 0, and we bring down the difference between the second terms, which is in this case -10x squared. We can then bring down the other terms. Now we simply repeat this process. 2x multiplied by 5x is equal to -10x squared, so we bring that number to the top of the bar in the x column. Multiplying the dividing polynomial by 5x gives us what we need to subtract. We are left with -2x, and we bring down the -3. Finally, we repeat the process one more time and find that -1 times 2x allows it to cancel the first term. This subtracts out perfectly, and there is no remainder, so we have our final answer. But what if we do get a remainder? The answer is very simple. In this problem, after we've taken all the steps, which I'll show here, we get a remainder of -9. Now, no integer can multiply by x to get -9, so just like regular long division, you turn the remainder into a fraction, making this our final answer. Now, what if the dividend doesn't have a natural progression of terms? In this next problem, the dividend does not have any terms with x squared, which becomes an issue when we get to this step in the division. The easiest way to compensate for this is to actually include the missing column. Here, I changed it to include a +0x squared. This makes it easier to subtract while keeping the equation equivalent. Now we can simply subtract -7x squared from 0x squared to get our new first term of 7x squared. We can then continue until we hit a remainder. Again, all we have to do is make a fraction out of the remainder. Then, we get our final answer.